Hi and welcome to this demo on MLOPS. The need for solid machine learning infrastructure is crucial as AI is much more than building models. In this demo, we introduce Kubeflow, an open source platform developed by Google and built into Google Cloud. We will cover the basic steps of how to create a small 3-task pipeline in GCP that pre-processes, trains and deploys a model in the cloud with CI triggers on push events and CD cloud functions that retrain outdated models. Kubeflow uses pipelines to orchestrate complicated workflows running on Kubernetes clusters. First, we set up the pipeline, go to the AI platform pipeline and create a new instance. GCP provides easy configuration. We just need to specify the cluster the pipeline will run on and deploy it. This may take up to 5 minutes. Each task in the Kubeflow pipeline is a separate Docker container, which makes scaling up easy and allows for running specific tasks independently. In this demo we have 3 containers: data preprocessing, model training and deployment. The deployment will check for existing instances on the AI platform and create a new version of that model. Each task requires a cloud build, a Docker file and a task script. First, we get the Python code to load the pipeline in our notebook on the AI platform. Kubeflow pipelines are defined in Python code. We define a function that serves as a wrapper for the pipeline. In it, we create a container op, which is a separate step in the pipeline. It needs 4 things: its name, the Docker image to run, arguments to pass into Docker image, and a file outputs, through which data is passed between containers. Based on the input and outputs of each container, Kubeflow automatically creates a DIG, where each node is a container of the pipeline in the correct order of execution. Next, we create a client that connects to the Kubeflow pipeline running in our cluster. Finally, we compile our pipeline and deploy it to the cluster. We can now check in the pipeline UI and see the pipeline running. We can also check the deployed model. The AI platform allows us to make API calls to make predictions. And as we can see, our model works fine. To incorporate CI, we use cloud triggers that will launch a cloud build job and rebuild the task container if new code gets pushed to its directory in the repository on Github. This can be done in the UI or in the Cloud Shell, and here we show a quick example of doing it in the UI. Here we showcase the trigger for the data task to be rebuilt when we edit and push a file to the data repository. And as we can see, it launches a cloud build job that rebuilds the image. Lastly, to incorporate CD, we set up a cloud function, which will automatically rerun the pipeline every time data is added to the data bucket, meaning that the model will always be trained on the most recent data. We use Python as the runtime and the same pipeline code as in the Jupyter notebook. We add the Kubeflow requirements, set the entry point and deploy the function. Now, every time new data is added to the bucket, the model will be automatically retrained and deployed. To test it, we add a new file to the bucket. Now, if we go to the pipeline UI, we can see that the new run was started and the pipeline is running. To conclude, applying DevOps practices in machine learning is becoming the new norm, and it's important to maintain a high quality of work. You've seen a sneak peek into all the functions GCP and Kubeflow offers for MLOPS. We hope you enjoyed this demo and are excited to try out Kubeflow on your own.